Before we set up ZePrA to color convert spot colors to CMYK and to multicolor, I would like to start by having a look at our demo file in Acrobat. So this is my spot color file, and if I'm looking into the output preview, I can see that there are a lot of spot colors in there which are used. If I want to have a look into how the alternate color space of each of the spot colors is defined, I can use pit stop and focus pit stop with the preview functionality. I can click in each of the spot colors, and for example this spot colors uses an alternate color space of LRB, and the LRB values are shown here. And this are exactly the LRB values which I've noted for below of each of those spot colors. This alternate color space is used by simple tools that convert spot colors to CMYK and to process colors. For example, the Acrobat tool convert colors. If I use this option, I can define that all my spot colors shall be converted to a profile, in this example the output intent, which is ISO-coded V2, and I want to convert those spot colors by using this tool. You'll see that after the conversion there is no spot color anymore, all the colors are converted. If you drive over here to each of the spot colors, that the Pantone Cool Gray is converted to 4 colors. A gradient from that spot color is as well converted completely to 4 colors. Each of the spot colors, for example this Pantone color, is as well converted to 4 colors, and my duplex image, which consisted out of black and Pantone 801C for example, is after the conversion as well converted to 4 colors. So basically the conversion is not good in terms of printability. And there is as well a little issue here. For example, this Pantone, this gradient from Pantone 717C to this Pantone color is really muddy. So there's probably an issue in the way how the conversion is done. So that's not properly done. So now let's have a look how the conversion is done with ZePrA. If we're here in the ZePrA overview dialog, we can simply use the auto setup functionality to create a queue. So in this queue I want to convert only the spot colors and want to make sure that I don't have any tag total area coverage higher than 330%. But I want to stay in my ISO-coded color space. So what I want to do is I want to optimize my total area coverage, so I use this automatic setup feature here. I'm selecting my ISO-coded tag 330 profile. If I do this, I'll give this a better name. So my configuration is nearly done. I just need to go here to my configuration, so you'll see my document color space is ISO-coded. I'm using this device link profile to convert to the same target color space. I just need to go to the options and disable the calculate ink saving, because for tag reduction it is not important. And I'm going to the convert spot colors, and this is the new thing. I'm going to the convert spot color dialog to set up the spot color conversion. I just need to enable this option here. And when enabling it, you'll see that other options get available. For example, here in this dialog, you can define how and with which spot color library you want to convert your spot colors. Typically, if you start, you don't have a lot of spot color libraries in here. Obviously, I'm having a lot of spot colors here because I have set my spot color libraries up already. Just assuming you have a spot color library, I will show you how to set this up later on. You just select the spot color library with which you want to convert each of the spot colors. So in your library, there's a list of all those spot colors in there that you want to convert. So you select the spot color library, and then you have a few options available. For example, how you want to do the conversion. So there are some options like prefer colorimetric visual matching or use as few channels as possible. I would like to select this option first. There is another option which allows you to define and specify what should happen with a spot color which is not available in your library. Either you don't want to have any spot colors in there, and regardless how it is converted, you just want that this is converted, then you use the first option, convert with the alternate color space, or you can keep that spot color or move the file to the arrow folder. I would select this option here to get notified by ZePrA. Basically, I'm done. So how it works is that you select your new queue, which we have set up here. You can go right-click and jump directly to the folder that has been created from ZePrA. And now you simply throw in that spot color document for the conversion. And as I have done a conversion already with the same spot color, ZePrA is recognizing, okay, there are some spot colors which he knows, so it is very fast in the conversion because the spot color conversion, the spot color calculation has been done already. If you want to know how the conversion has been done, you can first go here, for example, show job properties, and you see that all those spot colors in my document have been converted with ZePrA to those delta E values which are noted here. So if we want to see exactly how it's look like, you just go to the output folder, and here you find the converted file. And if you open this in Acrobat, you'll see again that there's no spot color in there. You see as well right away that the conversion from these vibrant colors is done correctly too, other than the conversion we've seen before. And you see as well, if you look a little bit closer into each of the spot colors, that for example this Pantone Cool Gray is only converted by using 49% of black. That means as well my gradient is using only black, which is a nice feature for the color conversion for printing basically. If I'm looking here into my Pantone 801C, you'll see that it is using only 100% cyan, and my duplex image after the conversion is as well only consisting out of 2 colors. So you will get a very good conversion in terms of accuracy and in terms of as little amount of channels as possible. I would like to do a conversion again, this time with another option. So I'm prefer colorimetric visual matching, and I'm converting the file again. Very simple. The original file is located in the done folder, so you simply drag this file again in the input folder and it will be converted with a new setting. So you get another PDF document in the same output folder with another kind of conversion, and if we are looking into that, I would like to point you to this one. So you see my Pantone 801C now consists not only out of 100%, but it adds as well some yellow in there. Obviously my conversion from the duplex image will have as well some yellow in there. My Pantone Cool Gray is still using just black. And I would like to show you in ZePrA why and how ZePrA has done this conversion. So we're going to ZePrA. And in the configuration, you will have the option here to define manually how a certain spot color shall be converted, but it can be used as well just to spot how a conversion is done. And we want to do this with 2 examples, with the Pantone Cool Gray. If a spot color is found from ZePrA, it will tell you in which library this spot color is available. So that means if you have the spot color put into different libraries with the same name, those libraries will be listed here. We want to convert with this library. You can say what kind of conversion you want to do. You can do the conversion with defined output values. This is the default setting, or with the alternate color space just for compatibility reasons. Or you can even say, I don't want to convert that spot color at all. It shall stay in my document. This is quite helpful if you have colors like die cuts, for example, that you don't want to convert. We keep the output value here. And here in the calculation method, we have the default setting is use the same method as in the configuration, which was the prefer colorimetric visual option here. You have other options as well. We will look into this. So you'll see how the conversion is done by ZePRA, and you'll see it is using 49%, 48.5% of black, which gives you a delta E of 0.6. If you disable the automatic feature, you have the possibility to define yourself how the conversion shall be done. So if you have better ideas or any idea for the way how you want to do the conversion, you can use and set up the values here manually. For example, if I put in the values that Acrobat was using for the conversion, you'll see which kind of delta E's you will come up with. So if I type in these values, these are exactly the values that we have seen before in the Acrobat conversion. You'll see that this is my original one. This is my converted to expected delta E and color. And the delta E's are noted here. So the delta E 2000 is 3.3. The delta E 76 is 3.7 in this example. So this is a very bad match. You can optimize that manually as well by clicking on this or this button, so it will optimize according to either delta E 2000 or delta E 76. If I click here, you will see you can get to a 0 delta E, yes, but by using this amount of CMYK, which is obviously not what we want to do because it's bad for printing. Using the automatic feature, you can get to an 0.6 delta E. There is barely no difference to be seen between the original LIB value and the to be expected LIB value. These are the values that are to be expected. So a little bit of the deviation, 0.6 delta E only, which gives you to that, which comes to this value. So a good kind of conversion, but just using black. Using the other color, the Pantone 801C, you'll see that it finds the spot color in the spot color library, and depending on the preferred calculation method, it is either using the yellow. By using the yellow, I can get to an 0.9 delta E 2000 or 2.8 delta E 76, which is a very good match. So there's no difference to be seen here. Or by use as few channels as possible, which I've processed the file with first. You'll see that it will get rid of the yellow. So it tries to minimize the channels. In this example, by just getting rid of the yellow, the error is not tremendously higher. It's just 2.5 delta E 2000, which seems to be an acceptable delta E tolerance for most of the packaging customers we're working with. So 2.5 is still acceptable, delta E 2000, I have to say. So this difference is a little bit spottable, yes, but it's still within the tolerance. And by using the way how the calculation is working, you can define either to be more exact by even don't using magenta and black, for example, or by using as few channels as possible. So there, depending on the color, depending on the calculation possibilities that are available with a certain spot color, you can fine-tuning the way how the conversion is done. So for printing, use as few channels as possible is the preferred method. If you're going to use inkjet systems, large format systems, which or you want to do proofing, then this option might be the better choice because you get a closer delta E. If we want to look why ZePRA prefers these values, you can go there and use again the delta E 2000 functionality. And what you're seeing is that it is not perfectly using 100% cyan normally. It prefers a little bit of magenta in here, but 2.2% of magenta, this is something you typically want to avoid in printing. So what you can do is put this to 0 and disable that function here and disable the black. And now you can again calculate the closest delta E 2000 that you can get by using just cyan and magenta, cyan and yellow, sorry. Clicking here, you'll see it will use 98% of cyan and 7.5% of yellow. And this is something which we even improve by using the automatic function, because a 98% means we are rasterizing a spot color. So we don't want to do that, and typically this is just 2% which is missing to not rasterizing the cyan. So the automatic feature tries to get to that point and brings it to 100%. And that's the reason why we have 100% cyan and 7.1% yellow, and only a delta E of 2000, delta E 2000 of 0.9, so which is a very good value. So that's the way how the conversion is done with ZePrA. So I started by explaining that you need to have a spot color library, and how to set up spot color libraries we are going to see now. We are going to the spot color option here, and in this area we'll have the manage color libraries option. In this area you can define to set up your new libraries. You can as well import some libraries, and this is the way how I have imported a lot of libraries in here, because we are supporting a lot of different file formats. We are supporting text files, we are supporting named color profiles, we are supporting Photoshop Acco spot color libraries, so you can export your Photoshop library there. We support CXF files and our internal CCF format. So a lot of different possibilities are there to import a spot color library. For example, if I'm going to import my spot color library, which I have here, which is an HKS spot color, I simply open that in here, and you'll see it is already available in my list. So you'll see all my spot colors that are in this Acco file, which was a Photoshop Acco file, can be imported this way very simply. If you're inside the spot color library, that's the spot color library I was using in my demo here, you'll see that each of the spot colors that I have in here is defined, for example, here this spot color with a full tone, with an LRB full tone. But there are as well some spot colors, for example this one, which is a remission, means it's a spectral value containing out of 10 single values. If I double click here, you can see what that means. It means that I don't have just only the 100% full tone, I have as well some tints. And that's very important, because with the tints, ZePrA has much more information and knows, okay, a 50%, for example, of that spot color shall have this LRB value. So that means giving ZePrA more information, like tints, the prediction of how a spot color is converted to your output color space is much, much, much higher. Therefore, the biggest work that you basically have to do is not the way how to set up the configuration. That's easy. You have seen that in my demo. The biggest work is to set up your spot color library. And typically, packaging customers are printing each of the spot colors on the press on different kind of substrates materials, and measure them inside either ZePrA or other tools and import those measurements. You can either use the measure functionality here or import measurement data, so that they have gradients of each of the spot colors on each of the substrate, because the same spot color, the same ink will look different on different kind of papers, and therefore you'll have different libraries with the same spot color name but with different LRB or spectral data. And the best is always to have spectral data, because the spectral data give you all the possibilities for a better matching of spot colors. And if you want to add a new spot color in there, you can simply go to the new button and put in the name of that spot color. The name is important. It must be exactly that name that you put into the document. And then you can define how you want that spot color to be measured. For example, you have a spot color gradient with 11 patches in there, including white. So you would select this one. So then you have the list out of each of the 10%, including white. And then you simply go to measure, and then you can measure with certain instruments that we're supporting. So that's the demonstration of how to set up a spot color library. We had the demonstration of how to convert spot colors to CMYK. And now finally I would like to show you an example how to get to the best results by using multicolor output conditions. Meaning, for example, in Indigo with 7 inks in there, you can get a much better representation of much more spot colors compared to CMYK. I'll have an example for this for you. For example, this one. So that's a spot color file which has 3 spot colors in there. There's one spot color which is a die cut, which is obviously not used as a spot color in its original sense, but more as a spot color to be used later on for cutting. So we want to keep the die cut in here. The other 2 spot colors, for example, the Pantone Reflex Blue and this red color, shall be converted to a 7-color process. So I've set up a configuration already, which is this one. I'm doing a conversion from iso-coated V2, because the document is set up in iso-coated and with additional spot colors, and to a 7-color process. I have set this up already, so I'm using a device link profile, so that's a very important step as well, creating a good device link that converts from iso-coated to 7 colors. So that's done already with our CoPRA application. And on the spot color part, you can see what's happening. For example, with my Pantone Reflex Blue, if I double click here, you'll see it will use all the 7 channels of my output device. And obviously, by using those 7 channels, you'll see that I can get a very close delta E 2000 of 1.0, which is typically not possible only with CMYK. You can see this quite easy by, if I'm disabling these options here and putting this to 0, and just using cyan, magenta, yellow, black for the calculation of the closest delta E, you'll see that you only get a 7.6 delta E 2000 by using cyan and magenta, and the match is obviously not that good. So that's the reason why packaging customers tend to use more inks on press to be able to represent much better the different spot colors into their 7-color printing process instead of using CMYK. So using the automatic feature, you get a delta E of 1.0 delta E 2000, which is a good match. So, and again, if I'm going to convert this document, this example document, right click and open the folder. So I'm going to that folder. If I'm converting the file, ZePrA will recognize it. It will be converted right away. In the output file, I'll find my converted file. And if I'm looking here, you can see that my spot color, my previous spot color, is converted now to a cyan, green and violet. My die cut is still in there because we wanted to keep the die cut for the conversion. And what's important as well, due to the device link, looking at the pure cyan, magenta, yellow, black colors, that's the advantage of applying a device link profile, because we wanted to make sure that the primary and secondary colors are not converted to 7 colors. So we make sure that the primary colors, for example, a cyan, is just consisting out of cyan at the end, or for example, my black is not contaminated with a lot of different colors. It's still black throughout the entire gradation. So that's an important functionality in this in this conversion as well. And only my spot colors are converted to my 7C. So that's the way how to work with ZePrA for converting from spot colors to CMYK and to multicolor.